Same part, different process. CNC machining or 3D printing. This isn't a debate about which one is better. It is about understanding what each one actually solves. CNC is subtractive manufacturing. Start with a solid material, cut everything away. What's left is the part, like carving a stone into sculpture. 3D printing works in reverse. Layer by layer, geometry grows from nothing. Same destination, completely opposite journey. CNC preserves the original material. Full density, predictable strength, proven reliability. That's why load-bearing, safety-critical parts are still machined, not printed. 3D printing offers geometric freedom, but freedom comes with a trade-off. Layer by layer, construction introduces directional weakness. Complex shape does not mean a stronger part. Shape is only half the problem. The harder challenge is fit. Bearing bores, precision threads, mating surfaces and tight tolerances. A single micron of error can seize a bearing, misalign an assembly, or fail a function test. This is where CNC still dominates, and likely always will. Traditional machining excels at the outside of a part. 3D printing changes a more fundamental question. What can exist inside? Internal channels, lattice structures, topology-optimized geometry that mimics bones. Strong where needed, hollow where not. Complexity is no longer a constraint, it's a design tool. Manufacturing changes how engineers think. Design for CNC means internalizing constraints. No deep cavities, no undercuts, no corners a tool cannot reach. The machine defines what's possible. 3D printing dissolves many of those boundaries. When the tool stops limiting geometry, the engineers can finally ask a purer question. What does this part actually need to do? CNC machining produces a more continuous surface, achieving excellent surface finish and roughness straight off the machine, ready for anodizing, coating, or precision texture. 3D printed parts carry the evidence of their process, visible layer lines that often requires post-processing to reach the same standard. For surface-critical applications, this is a real cost. In real production environments, the question is rarely CNC machining or 3D printing. It's usually both, and often used together. 3D printed compresses the iteration cycle. Faster prototypes, faster validation, faster decisions. CNC machining delivers precision and strength that production demands. One accelerates the journey, the other defines the destination, and sometimes they travel together. Great engineers don't pick a side. They read the problem first. Does this part need absolute strength and precision? Machine it. Does it need geometry that's never been manufacturable before? Print it. The best manufacturing decision isn't about which process is superior. It's about which one serves the part and the problem behind it. Follow JLCCNC for more CNC insights.